Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Asharul Bezaimi, the presenter of this paper review of mechanical performance of oil palm fiber and coconut fiber as an additional material in concrete. The author of this paper is Muhammad Asharul Bezaimi, Dr. Nur Fahayu Arifin, Sharifah Mazura Said Mohsin, Abdul Muiz Hasim, and Nurul Natasha Nasruddin. My presentation outline is introduction, problem statement, objective, result and discussion, conclusion, and last is recommendation. Concrete and construction. Construction sector grew 42.6% in the second quarter of 2021, which is 28.2 billion. The mining output gained further is 10.3% to 20.7% in 2021. In contrast, the manufacturing activity contracted from negative 0.2% to 29.8%. This was followed by the quarry crushing and breaking of granite of 1,960 million, which is 20.5%, and sand extraction of 846.9 million at 11.9%. My problem statement is the cracking in concrete. Concrete is a material that is very simple to work with. However, it is not adequately worked on. It might cause major issue. Cracking, curling, scaling, and a variety of other issues are examples of concrete issue. Let's go to the crack. Crack is in concrete is a common issue that can give a huge impact to whole structure or building. There is several types of crack that are classified, which are flexural crack, thermal crack, and others. The flexural crack will form when the tensile stress caused by the bending exceeds the tensile strength of the concrete. My review paper focus point is on the coconut fiber or the coir fiber, and the second one is the oil palm fiber. First is the coir fiber. More than 60 million metric tons of coconut produced in 2019 worldwide. Malaysia has created more than 12% or 600 kilotons of coconut waste per year. The waste will have a negative impact on the environment during its disposal process. The demand on the coconut milk and water highly rise due to the rising health consciousness. The coconut fiber is a natural fiber derived from the outer husk of a coconut, and it is a component of the coconut fruit. Okay, next is the oil palm fiber. Malaysia is one of the largest producer and exporter of oil palm production. The statistics show that the increase in change of oil palm production from 5.97% to 11.49% from 2020 to 2021. The increase of the production brought to the increase in oil palm waste, and in Malaysia there are more than 400 palm oil mills, and each produce huge amount of waste, which are currently not fully utilized and polluting the environment. The oil palm fiber is made from the empty fruit branch that are discarded from the oil palm fruit is extracted. For my objective, the hypotheses that have been proposed are: how is the strength potential of natural fiber as a replacement in concrete? Second is the stress on concrete is increased with the fiber replacement? And the third one is the length fiber is correlation with the quantity of replacement in concrete. Now we will discuss on the mechanical properties of coir fiber as additional in concrete. Okay, this table shows the compressive strength of the coir fiber that has been done by the other researcher. First one is Ajudan. He has 3 replacement, which is 1 to 3%, and the data show that his data is increased strength higher than the control one. Second is P. Srinidhi. She have 3 data also and show an increased strength higher than the control one. And the third one is M.A. Othman. He only have two data, which is 0.2 and 0.4, but had an increased data, which is 7.75 to 8.63, higher than the control one, 6.84. And last one is VSUD, has 5 data, but the trend show decreased trend from 66.52 to 53.37, below than the control one, 64.93. And next is pleasure strength of the coil fiber. For the first researcher, Achudan, has 3 data, and the trend of his data is decreasing, below than the control one. Second is Skiyadav. Skiyadav have 5 data, and his data show an increasing trend from 2.9 to 4.83, higher than the control one. The third one is P. Srinidhi, have 3 data only, which is, and her data have increased trend from 6.78 to 8.5, higher than the control one, 6.63. And the last one is R. Rumbayan. R. Rumbayan have 4 data, which is 0.2, 0.5, 0.75 and 1, and her data show the decreased trend, below than the control one. Now is the last data of the tensile strength of the coil fiber. First, W. Ahmad have 4 data, and his data show an increased trend from 3.02 to 3.54, higher than the control. The second one is P. Srinidhi, have 3 data, and her data have increased data from 3.41 to 4.06, higher than the control also. And the third one is V.S. Uday, has 5 data, from 4.54 to 3.58, show a decreased trend, below than the control one, 4.39. And the last one is S.K. Yadav, have also 5 data, and his data show an increased trend from 2.88 to 4.57, higher than the control one. Okay, now is the hypothesis of the coil fiber part. First, the compressive strength show that the more addition of coil fiber in concrete, the higher strength of concrete, but at the limitation of 1 to 3% only. Second one is stress of concrete increase along with the purpose of fiber as a reinforcement in concrete. And next is the tensile strength increase when the fiber length and the percentage is increased. The fourth one is the length of fiber give high effect to the strength of the concrete, either increase or decrease. Next is the mechanical properties of oil pump fiber as additional in concrete. Okay, now is the compressive strength of the oil pump fiber by the previous researcher. The first one is Mr. N. Gagandaran. He has 3 replacements, and his replacement show an increasing trend, which is 29.48 to 31.11, higher than the control one. Second is S.W. Lee, have 3 replacements, and his replacement show also an increasing trend line from 49.5 to 55.1, higher than the control one, 47.3. The third one is Alposit. Alposit data is in 100 because she used the mortar size. Her data show then decreasing strength from 376.6 to 288.5, and it is lower than the control one. The last one is V. Gunalanan. He has 4 different replacements, which is 5%, 10%, 15% and 20%, and his data show a decreased trend, but higher than the control one. Okay, next is the flexural strength of the oil pump fiber. For the first researcher, Mr. M. Gagandharan has 3 replacements, and his replacements show an increasing trend from 19 to 22, higher than the control one. The second is Al Pusit, which is have Al Pusit have 3 replacements, which is 5, 10, and 15, but his replacement should decrease trend from 85.2 to 77.4. And the last one is V Gunalaan. V Gunalaan have a decreased trend from 2.3 to 1.4, which and below than the control one. Next is the tensile strength of the oil palm fiber. For this fiber, there is only available for 2 researchers only, because mostly the other researcher is lack of knowledge of this data. Okay, let's go for the first one. Is N. Gagadaran has shown that the trend of his data is increasing from 7.002 to 7.49, higher than the control one, 6.57. And the second one is Momo. Momo have 6 data, which is 0.5, 1, 1.5, 2, 3, and 4, and her data show a decreased trend from 3.45 to 2.94, and it is lower than the control one, 3.33. Now is the hypothesis of the oil palm fiber. The comprehensive data of previous research show increase in strength along with the replacement, but they are declined when the length of the fiber is longer than 5 cm. Second, inferior data suppose the strength is increased with the increasing of length, and the decline happen due to the moisture content in concrete or during the casting process. The third one is in tensile. The strength is increased affected by the length of the fiber that is below than the 5 cm. Okay, for the conclusion, the addition of the fiber in the concrete increase the strength of concrete. The second one is the stress of concrete increase due to the properties in nature of the natural fiber. And the last one is the correlation of concrete strength with the fiber length show that the range of fiber below 5 cm can increase the strength of the concrete. Okay, for the recommendation, first, it is necessary to research the influence of natural fiber on high strength concrete in order to employ the fiber in industrial and commercial construction. Due to the lack of mechanical characteristics, the application of natural fiber in reinforced structure should be assessed. Second is, admixture can also be used to reduce the number of void caused by the presence of the fiber in concrete. It has the potential to improve the concrete strength. The third one is, it was observed that adding the fiber to the mix in excess of 5% of the seaming weight had no influence on the result. As a consequence, adding fiber to the concrete improved its strength the most when it between 0 to 3% and the total weight of seaming in the mix. The fourth one is, expand the research into the use of oil palm fiber mixed with another byproduct in the concrete mix design. And the last one is, in concrete mix design, use variety, length and replacement proportional of natural fiber. That's all for me. Thank you.